Hello, and welcome to this lesson on solving and graphing linear inequalities. So these can be inequalities in slope-intercept form. So y equals mx plus b. We're going to have x's and y's. We're going to be graphing on a coordinate grid as opposed to just a straight number line, as we've been in the past. Did you know that inequalities are great for figuring out the cost effectiveness of a season pass, or one of those things like you buy a bunch of things at one time that kind of give you a discount? So it says here like a Hershey Park season pass costs $159. A discounted ticket costs $49 from Giant Foods. Usually you can get them a bit cheaper there. How many times would you have to go to the park to make it the season pass worth the cost? That's a simple inequality, but that's the kind of thing that you could do frequently. My wife and I used to have a membership to a rock climbing gym, and it was like $1,000 for a year for the family. And we figured out, well, how many times would we go? Like, are we actually going to go 15 times over the year to make it worth the cost? And we've decided that it was worth the cost at the time. So that kind of thing, it's pretty useful. Vocabulary, we have two vocab words. First one is just a linear inequality in two variables. That's just two variables inside one linear inequality. So it's gonna be like the x and the y. So like y is less than 3x plus 2. There you go. It's an inequality with two variables. And a solution to a linear inequality in two variables, it's going to be an ordered pair, just like before. The solution to this would be an x and a y, or a whole bunch of x's and y's that eventually made a line. Well, it's going to be an ordered pair that produces a true statement when x and y are substituted into the inequality. So this also will make a line with a little bit extra. So we want to determine whether an ordered pair is a solution. So if I just gave you this inequality here and this point here, and we say, is that point a solution to this inequality? I'd like to be able to say yes or no. Is it an answer? And it's as easy as you might imagine. We're going to take the x and the y coordinates and plug them in for x and y. And do the math. So if I do the math on the left side of the problem, 3 times 0 is 0. 0 minus 0 is 0. And we get down to this point where we have, I simplified the left side here. 0 is less than or equal to 6. Is that true? Is 0 less than or equal to 6? Yes, it is less than. So since this is true, that point is a solution. So 0, 0 is a solution. That's what we found. Because the math worked out, it is an answer to the problem. Letter B. So we're going to take the x value and plug it in for the x. We're going to take the y value and plug it in for the y and see what happens. So 2 times 4 is less than 8. Now, this -0 thing doesn't make much sense. There's no such thing as a -0, so I'm just going to make it 0. And then 0 plus, 2 times 4 is 8. So 0 plus 8, that's going to be 8. So I've simplified this down to that. 2 times 4 is 8, plus 0 is still 8. Is this true? Is 8 less than 8? No, that's false. That's not true. 8 is not less than 8. It's equal to. So 0, 4 is not a solution. When we plug the point in, the math did not work out. It came up something that was false. So this is not a solution. Okay, so I did 2, and I'll leave them up there. I'd like you to do the next two letters, C and D, please. So go ahead and pause the video, do them on your own. When you're ready to continue, hit play, and we'll go through them together. Okay. So you plugged in 0 for x and 0 for y. That gave you 0 is greater than 8. That greater than kind of looks like a 7. There, that's better. Which is false. 0 is not bigger than 8. So 0, 0 is not a solution. Letter D. You plugged in the x value for x, the y value for y, got -3 plus 2 times 5 is less than 8. That's 10 plus -3. That's 7 is less than 8. That's true. That's true. So 3, 5 is a solution. Okay, so it's simple as just plugging in a point for the equation and seeing if it's true. Now, moving on to the next step. So we now know how to check if a solution is true. Let's figure out how we can graph this thing. So graphing a linear inequality is almost exactly like graphing an equation. So things that we need to remember. So we need to remember that slope-intercept form. That thing. So this is our slope. We prefer our slope as a fraction. This is our y-intercept. That's where the line crosses the y-axis. So when we're going to graph this, we're going to start by graphing our y-intercept. So I'm going to put a dot at -3 on the y-axis. -3 on the y-axis. That's where our line crosses the y-axis. Then our slope is 4. As a rise of a run, that is up 4 over 1. Up 4 over 1. 1, 2, 3, 4 over 1. Now, we are not going to draw a straight line through these just yet, because there's some things we've got to do. There's a difference here. Normally, we would just draw a line straight through these 3 points and we'd be done. That's an equation. This is an inequality. So, do you remember how with an inequality, you have a hollow dot and a solid dot? And you get that one from doing a less than and a greater than. The solid dot came from a less than or equal to, greater than or equal to. Well, when you're talking about a linear inequality like this on a coordinate graph, we don't have dots that would be a hollow dot or a solid dot. We have lines. So we need to show a hollow line or a solid line. Now the solid line, like you might be able to imagine, is just a solid line. But that's not this. Look, this is just greater than. This would not be a solid line through these 3 points. This would be a hollow line. And the way we show a hollow line is with a dotted line. So we need to put a dotted line through these 3. Now, if you're using Notability like me, there's a couple different strategies you can use. One is just the ugly way, just dot, 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 dot. That works fine. The other way, the other way is if you draw a straight line, because some people really like their lines to be straight, and then go back through with a white marker and just kind of whiting out parts of it. Now it looks like a dotted line. It's up to you. I really don't care. As long as you're showing it's a dotted line, that's what matters. Okay, now before, when we had a number line, we did our dot. In this case, we would have a hollow dot, and then normally there would be a shade. We'd shade either to the left or to the right, based off this symbol. If it was a greater than, we shaded to the right. If it was a less than, we shaded to the left. Well, this is kind of a big open area. It's not necessarily a right and left. So we're going to interpret this. This is a greater than, right? This greater than symbol, when we have a big, huge open area, means we're actually going to shade above the line. This area up here, this is the stuff greater than the line, and everything below it is less than. Now, if you're ever unsure where to shade, check this out. You could do exactly what we did in the previous few problems. You could go, I'm going to pick some point over here. I would almost always pick the origin. Check this out. If I plug in the origin, is that a solution to this problem? 0 is greater than -3. Yes, 0 is bigger than -3, which means this is a solution. And in fact, everything on this side of the line will be a solution. So my shade is this. So instead of shading on a number line, we are shading half of a graph, half of a coordinate plane. Okay, a little weird for the first problem. So instead of having dots, solid dot and hollow dot, we have solid line and hollow line. Instead of shading to the left and to the right, we're shading kind of above it is greater than, and below it is less than. And that's it. Now, one thing to mention while we're here. So that point is definitely a solution. It's in the shaded region. This point is definitely not a solution. It is not in the shaded region. What about this point right here? Would that be a solution? It's like on the line. Well, in this problem, he would not be a solution because he's on a dotted line. And remember, just like this, the hollow dot, that was not a solution. It's not in the shaded region. It's kind of just the border of the shaded region. So this is not a solution. If I plug in the point 0, -3, 0 for x, -3 for y, we're going to get -3 is greater than -3, which is not true. It is not a solution. If this was a solid line, that point would be a solution. Okay? Just a little extra, but it's good information to know. Letter B. So not all the time will our lines be in slope-intercept form for us. We may have to do a little bit of solving, like now. So I'm going to subtract x on both sides. I'm trying to make it look like that. So 2y is less than or equal to -x. I'll put the +0 for now. Divide by 2 on both sides. These cancel out. Y is less than or equal to -1/2 x plus 0. So I'm keeping my 0 to make it look like slope-intercept form up there. So that tells me that this is my slope, and that is my y-intercept. So when I go to graph this, my line is going through the origin. That's crossing the y-axis at 0. My slope is -1/2, meaning from this point, I'm going to go down 1 over 2. Remember, over is always to the right. Down 1 over 2. Down 1 over 2. And in reverse. I have to decide if this is going to be a solid line or a hollow line, a dotted line. Well, looking at our inequality, this would be a solid dot, so this will be a solid line. Now our shade. We have to decide, are we shading greater than the line above it or less than the line below it? This is a less than. It looks like an L. Less than. So a less than, we shade lower than the line. I'll take my highlighter and I'm just going to shade everything down here. Might have got a little bit ambitious at the top. I can scoot it down. There, close enough. Now, in this graph, we know that would be a solution because it's in the shaded region. We know this would not be a solution because it's not anywhere near the shaded region. But we also know that this point on the line is a solution because the solid line counts as part of the shaded region. So this is a solution as well. Okay, graph of linear equality in two variables. So I did 2, you do 1. Go ahead and pause the video, try this right now. When you're ready to continue, hit play, and we will go through it together. All right, so let's see here. We would subtract x on both sides. 4y is less than negative x minus 8. Divide by 4 on both sides, and y is less than negative 1/4 x minus 2. Now, it has not happened yet, but it's something to be cautious of. If we would have to divide by a negative, let's say this 4 was a negative right here, and we divided by a negative, we would change the direction of the inequality. It's still an inequality, and all those other rules still apply. Hasn't happened yet, but each problem I'm thinking, ooh, maybe it'll happen this time. So we are going to graph that, or you should have graphed that. If you didn't yet, maybe you want to pause the video and give it a shot right now. See if you're good. See if you can graph this. Your y-intercept is -2. That's right there. Your slope is negative 1/4. That is down 1/4. Now I can't go any more down this way, so I'm going to do the opposite. I'm going to go up 1/4 the wrong way. And I don't think I can get any more. So what I'm going to do is I'm going to make my line. I'm going to try to make my line extend the whole way to the edge. My line should be a dotted line. I'm trying to turn my iPad so I can do this neatly. Yeah, that's close enough. As long as your dots are right where they belong, the line can be a little wibbly wobbly. It's not a big deal. And our shade. Am I shading greater than the line or less than the line? Above or lower? We are shading less than the line, lower than the line. So your shade should be everywhere down here. And that's it. That's the whole problem. So when you get some practice at this and you realize they're really not that bad, they're really fairly quick and easy. Okay. Graphing a linear inequality in one variable. So on a coordinate plane, we can still graph something like this or this. Now, in order to do that, the way we did this in the past is we would make a little XY table. This is really the line y equals -3. The only difference between this and that is this would either be a solid line or a dotted line, and the shade. But the line itself is this line here. So let's figure this out. If I was going to graph this, what would it look like? So we remember that in this case, it says y equals -3. So all of our y values are -3. That's the only thing they're allowed to be. Y is -3. But the x values can be anything we want them to be. So when we graph this, 0, -3, 1, -3, 2, -3, 3, -3, 4, -3. We see the pattern. It's going to be a horizontal line right here. Now that we have our line, let's go back to the inequality. So this line would be a solid line because of the or equal to. And my shade. I am going to be shading, I'm going to be shading greater than the line. Greater than would be above it. These are all the values where y is bigger than -3. And that's our answer. Letter B. XY table. I'm really thinking about the line x equals -1. So -1, -1, -1. Just throwing a bunch of them in there. The y values are allowed to be anything we want, so I'm just going to do this again because it's easy, it's quick. So -1, 0, -1, 1, -1, 2, -1, 3. Okay, I have enough that I can see the pattern. It's going to be a vertical line right here. My line needs to be a dotted line. There's no or equal to, so this I'm going to make a dotted line. My shade is a less than. Uh-oh. We can't shade above the line. This line is a vertical line. Okay, so now we got to think. So on this line, on this graph, which way would have x values less than -1? It would be over here. This is -1, -2, -3, -4. These are less than -1. Over here, x value is 0, 1, 2, 3, 4. So we're going to shade left. These are where the x values are less than -1. Okay, make a table, graph. One for you. Go ahead and pause the video and do it right now. All right, so I'm thinking about the line y equals 5. That would be x, y, all of my y values are 5. 0, 1, 2, 3, 4. That gives us 0, 1, 2, 3, 4, 5 is right there. 1, 5, 2, 5, 3, 5. And I have enough to see the pattern, to see the line. Going back to the inequality, this line is a hollow line because it's not or equal to. It is a hollow line, and our shade, this is a greater than. So we are shading greater than this. That would be above the line. Greater than, less than. Okay, last two of this type. If you could quickly pause the video and do these two right now. When you're ready to continue, hit play, and we'll go through them together. All right, you should have, for this one, I'm just going to go straight into the graph because I can. You should have a solid line right here where y is negative, or y is positive 3, and your shade should be lower than, less than the line. So that's what your graph should look like. Number 7, you should have a hollow line, a dotted line right here where x is equal to -2, and you should be shading less than, which is right there. So our graphs will look the same, even if our work is slightly different. Okay, applications. A farmer can make $8 per bushel of peaches and $4 per bushel of cherries. A bushel is like a big basket. The farmer wants to make at least $350 selling his fruit. Write and graph an inequality that represents how many bushels the farmer needs to sell of each type of fruit. Okay, so I like to do the verbal model first. So I'm thinking about this. So he makes $8 per bushel of peaches. So 8 times by each basket of peaches. And he makes, what was it, 4? Yeah. He also makes $4 per bushel of cherries. So this is how much money he's making. He's making $8 per basket of peaches, $4 per basket of cherries, and he wants that money to be at least $350. At least $350 would be bigger than or equal to $350. Now, slight problem maybe. Our variable is in P's and C's, and we don't have a P and C variable here. We have X and Y axis. So we got two options. One, we can change P's and C's to X's and Y's and just somewhere say, well, X is the peaches and Y is the cherries. We could do that, fine. We could just, when we go down here and label, we can label like number of peaches, and that would make like the peaches our X variable, and then like number of cherries, and that'd make the cherries the Y variable. It's up to you, really. I personally, I kind of like having the X's and Y's, so I mean, it works really the same. So I'm going to say X equals number of peaches, Y equals number of cherries, and then in my equation I would just change that. There's my peaches and there's my cherries. That's what I like to do. You could leave it with the P's and C's. So now I'm going to subtract 8x on both sides. I am trying to get it to slope-intercept form. Negative 8x plus 350. Divide by 4 on both sides, and we have y is greater than or equal to negative 2x plus, I don't know, 350 divided by 4. 87.5. So there's the equation we're going to try to graph. So we need labels. The way I have it, I said X is peaches. So we're going to put bushels of peaches here and bushels of cherries here. So peaches and cherries. I can see that my y-axis, my y-intercept, needs to go up to at least 90. Well, if I count by tens, that takes me up to 100. That's a pretty good thing. So let's do that. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. My 80's a little ugly, but I think we got the picture there. And if possible, I like to use the same scale on both the x and the y axis. It makes a lot of the work easier. So I'm going to do that too. 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And now we graph. I'm going to change color just to keep things separate here. So 87.5. That would be really darn close to 90. Like here somewhere. I mean, that's 90. That's 80. So up here somewhere. I mean, it's an estimate. Our slope is, I can see down here, -2. So from here, we can go down 2 over 1. We are only allowed to do that because we have the same scale on the x and y axis, because in this case, down 2 boxes is down 20, right? So we're counting by 10, down 20, and over 1, it's 10. That is the same thing as down 2 over 1. If you used a different scale on each axis, then you have to really pay attention to what down 2 over 1 would look like with a different scale. Okay? Because we use the same scale on each axis, it makes this very easy. Down 20 over 10. Down 20 over 10. Down 20 over 10. Down 20 over 10. And that's about as good as we're going to get. I can see from my inequality here that this is a solid line, or should be a solid line. It's or equal to. And I can see from my inequality this is a greater than. So I'm going to be shading above the line, everything above it. So that is all of this stuff. And there we have it. So now we know how many bushels of peaches and cherries he would need to sell in order to reach the $350. So he could sell, say, what's this? This would be 60 peaches and 20 cherries. He would get more than 350 bucks. If he sold this, 10 peaches and 50 cherries, he would not have enough money. That is less than the line. If he sold something right on this line, that would give him exactly 350 bucks. And the further away he gets, out here, 100 of each, well, he's sitting at $1,200 right here. I mean, he'd be sell 100 of these, 800, 100 of these, it'd be $400. Altogether, that's $1,200. So the further away from the line, the more money he's making. The closer to the line is closer to that 350. Right on is exactly 350, and then down here would be less than 350. This should be the last problem. Yep. And this is one for you. So, if you could please pause the video and do this right now. When you're ready to continue, hit play. We'll go through it together. It says here, Deadpool from Marvel Comics can eat half a chimichanga per minute. He could also eat 1 taco per minute. In a food eating contest, he wants to eat at least 80 chimichangas and tacos combined. Write and graph an inequality showing how many minutes of eating each type of food Deadpool would need to meet his goal. So that inequality, to me, I'm going to say x equals chimichangas per minute. Y is equal to the taco per minute. And so my equation would look like this. 1/2 x plus 1y, right? He's half a chimichanga per minute. Actually, I guess this wouldn't be per minute. This would just be chimichangas and tacos. Because then half of a chimichanga per minute, half of a taco per minute, and then in a food eating contest, he wants to eat at least 80. So greater than or equal to 80. So there is our equation. We wrote. Now we need to solve and graph. Solve. Minus 1/2 x on both sides. 1y is greater than or equal to negative 1/2 x plus 80. We don't really need to divide by 1. That's useless. That's a ghost 1 anyways. See? He's gone. And it's the exact same thing. So we could stop. Whoa. I have my eraser still out. We could stop right there. Now, graph. This graph actually is going to look fairly similar to the previous graph. We need a scale. I'm going to put X's as my chimichangas. Y's, because I already have Y as tacos, I'm going to put tacos on my Y axis. We need a Y intercept of 80. So I think counting by tens is good again. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And again, I like to use the same scale if I can on both axes. So I'm going to. Oops, I almost put 30. 40, 60, 80, 100. Change color to make the graph a bit more visible. Now, my y-intercept here is 80. So my y-intercept is 80. My slope is -1/2. That's down 1 over 2. 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 And it's okay that our graph goes off. We don't need to know exactly where this crosses. We could figure it out if we wanted to, but right now we don't need to. My line is going to be a solid line because of this or equal to. And my shade is going to be greater than. Greater than is above. There we go. And so now we can see that, I mean, if he ate just straight tacos, he'd eat tacos for 80 minutes, and that'd give him 80 tacos. Remember, he ate like 1 per minute. If he ate, what's this? This would be, this is the point, what? 60, 50. So he could eat 60 chimichangas and 50 tacos, and that'd be exactly 80 minutes. Remember, right on this line is exactly the 80 minutes. Where anything above the line, it's still within his goal. So if he ate 100 of these and 100 of those, that would be his goal. All right. Summary. How do you know which side of the line you shade when graphing a linear inequality? So it's a nice basic summary, but it's something that's very important for the lesson. How do you know what side of the line to shade? Go ahead and pause the video, put down a thought. All right. You know what side of the line to shade. If it's a less than, you shade lower than the line. If it's a greater than, you shade above the line. The exception being when you have only one variable, like here. Well, if it's less than, you still shade lower than the line, but if it's a completely vertical line, like this one was, we kind of go back to the left and right thing, because there's no above of a straight up and down line. And that's it. In each of the problems, it was, less than, lower than the line. Greater than, above the line. Thank you so much for watching this lesson. Until next time, toodles.